Hey guys, welcome to 6.4. So hopefully you're watching this for Thursday or Friday's class. Um, this is going to be about definite integrals, calculator integration, etc. So a definite integral we call as an integral that is written with bounds. So if I have something like from a to b, and here we have f of x dx. This is a definite integral because we have bounds. And what this is really saying is this is going to be the, we'll say, signed area. We'll talk about that in a second. From x equals a to x equals b. Okay, so this is actually how you're going to find the exact area under a curve. We talked last time about using Riemann sums to estimate. Now remember that ended up being like f of x times our width of our rectangles. Well, what's happening here is this is our f of x, this is our height, and this d of x is representing the width of each rectangle. And what happens is we're gonna make these widths infinitesimally small, so we have an infinite amount of rectangles, and that's why this ends up equaling the area. Now, on your calculator, I'm going to show you how to do it on T84. I'll show you in class how to do it on T89 as well. I'm just going to go ahead and pull up my T89 here. Oops, I want to see them both here. Let's see if that's possible. All right, well, we're going to have to switch out here. And so in this case, we are going to, so you can see both things. Here we're going to be looking at the integral from, looking at this integral here of negative x cubed minus 6x from negative 3 to 1. So on your TI-84, you're going to turn it on. And to get an integral, you're going to go ahead and hit that math button. And then 9, if you go down to 9, or you can just hit 9, 9 says Fn in integral. So I'm going to go ahead and hit 9. And we're just going to fill in the blanks. So we're going to go from negative 3 and go up to 1. And then our inside, we're going to have x cubed minus 6x. You could be following along with me. I forgot my minus there. So minus 6x. And then we need a dx to say that we're integrating with respect to x. And when I hit enter, 4 happens. Well, what does that actually mean? Let's take a look at this graph and kind of take a look at it. So I'm going to go ahead and graph x cubed minus 6x. And let's go ahead and look at this graph. So here we have that cubic. It goes through 0, 0, and it goes through the square root of 6, it looks like, and negative square root of 6. So negative 3 is over here, 1's here. What do I mean by signed area? Well, this calculator is pretty cool. If I hit second calc, it'll show what I mean by our area here. If I hit number 7, so that's our integral here of f of x. Lower limit, we're going to go ahead and hit negative 3. Upper limit, I'm going to hit 1. And what you can see is we end up calculating, so all of the shaded area here is what goes into it, and that gives us 4. If we're below the x-axis, that's going to be negative, and if we're above, it's positive. So this has, I'm going to say, a net area of positive 4. If we had more curve in the below the x-axis, we would probably have a negative area. Okay, so here we end up with negative 4. Or positive 4, excuse me. Now, if we did the exact same thing, and we did it from negative root 6 to root 6. Well, let's go ahead and see what would happen on this curve. I'm just going to go ahead and copy that. And we're going to go from negative root 6 to positive root 6. And we end up with 0. And we can see that if we wanted to on the graph, if I go negative root 6 to positive root 6, oops, hold on, you can see that we end up with 0. There shouldn't be anything on this left-hand side. I think that's just from before. Okay, so notice that the area above and area below equal each other out, so that means the signed area, we'll say, is 0. Okay? All right, let's continue. Now, here's asking us to find the area to evaluate the integral from 0 to 3 of 2x minus 1. We're actually going to be using geometry to do this. If we think about graphing 2x minus 1, well, we know at 0 that we're at a height of 1. At a half is where it ends up equaling 0. And then we know that at 3, if I plug this in, we end up with 6 minus 1 gives us 5. So at 3, we're up here at 5. And so this is our graph here. Now, we can go ahead and actually find the area of each one of these triangles to find this integral, because remember, this integral is just our signed area. So here we have a 1 by 1/2 triangle. So this has an area of a fourth. And here we have a 2.5 by 5. So 2.5 times 5 times a half. And if we plug that into a calculator, 2.5 times 5 times a half, we end up with 6.25. So our area in this case, or our integral, is going to equal 6.5. And we can plug that into a calculator to check. Okay. Now, if we want to set up a definite integral, so here we just want to say, what would you type into a calculator if you want to find the area of our shaded region, and our curve is y equals 2x squared minus 3x plus 2, and we're going from 0 to 2, well, we could go ahead and write that as the integral from 0 to 2 of 2x squared minus 3x plus 2. We're going to put parentheses around it and our dx, and that is going to actually give me my area. Let's talk about, I'm going to go ahead and go to the next section. We're going to skip the discovering fundamental theorem of calculus. We might talk about that in class. But our fundamental theorem of calculus says that if you have f prime as a continuous function, then the integral of f prime from a to b is going to be our integral of f prime, which I'm going to say is f of x, and we're going to plug in b and a to get f of b minus f of a. So what we're going to do is we're going to integrate and we're going to plug in b and a, and then our last step is we're going to say what f of b minus f of a is. Okay, this is what we call the fundamental theorem of calculus. So it's really important for integration. It tells us the area. Okay. So in this case, we are evaluating the integral from 0 to 4 of 2 times the square root of y plus 1. I'm going to rewrite this as the integral from 0 to 4 of 2y to the 1/2 power plus 1. And now we can go ahead and integrate. So remember, when we integrate, we bump our power up by 1 and divide by our new power. So we have 2y to the 3/2. We got to divide by 3/2, so it's the same as multiplying by 2/3. Plus y. We can actually ignore our c when we do that because we're going to be subtracting them when we do this. So we'll talk about that in class a little bit more. So we're going to plug in 4 and we're going to plug in 0. So when we plug in 4, we get 2/3 times 2, so 4/3. When we plug in 4 to the 3/2 power, we're going to take the square root, get 2, cube it, get 8, plus 4. And then minus, we're going to plug in 0. And you can see we'll just get 0. So we end up with 32/3 plus 4. 32/3 plus 4, which ends up equaling 44/3 would be our answer there. Okay, and you can check that with a calculator. This we already did as an example on our calculator. We're going to show it using our rule here. So let's go ahead and plug in. So we're going to go ahead and integrate. So we're going to end up with 1/4 x to the 4th minus, well, we're going to make that x squared. So divide the 6 by 2 gives us 3 minus 3x squared. And we're going to be plugging in -3, and we're going to be plugging in 1. So when we go ahead and plug in 1, so I'm going to put some parentheses around it. We're going to plug in 1, we get 1/4 minus 3. And now we're going to go ahead and subtract, and we're going to plug in 3. 3 to the 4th, -3 to the 4th is 81, so we have 81/4. And then we have 9 times 3 gives us 27, so minus 27. Okay. Let's go ahead and distribute that negative in there. So we end up with 1/4. I'm going to change the order of things. 1/4 minus 81/4 minus 3 plus 27. Well, if we look at 1/4 minus 81/4, that gives us -80/4, which is -20. And then we have -3 plus 27 gives us positive 24. And so we end up with 4, which is what our calculator gave us. Okay, cool. So now we can actually find the area under the curve. Let's do one more. So we're going to look at sine of x dx from pi over 4 to pi. And we are going to integrate that. So the integral of sine is going to be negative cosine. And we're going to plug in pi over 4, and we're going to plug in pi. Well, I know that cosine, well, we can go ahead and like this. So we'll have cosine of pi minus the negative of cosine pi over 4. So if I plug in pi into cosine, we end up getting -1, and then we're going to take the negative of that, so it's going to be positive 1. And then minus, those cancel out, plus cosine of pi over 4, which is √2/2. And we end up with 1 plus √2/2 as simplified as we can get there. I guess we could make that, if we wanted to combine it, we could say 2 plus √2/2, but we don't have to. Okay. Last one. So if we know, and this happens a lot on the AP exam, if we know that the integral from a to b of f prime of x is f of b minus f of a, we can say that we could move things around and say that basically adding f of a to the other side, that f of b is equal to f of a plus that integral. Okay. So in this case, we have f prime of x equals 3x squared plus 3, and we're told that f of 0 is 4, and we want to find f of 2 without a calculator. So we can say that f of 2 is going to be equal to f of 0 plus the integral from 0 to 2 of 3x squared plus 3. Okay. I often, to be honest, might start this as the integral from 0 to 2 equals f of 2 of 0, and then just add that f of 0 over. But we're just going to start with that step here. Now we know that f of 0 is 4. Now we got to do this integral. So we're going to add 1 to our power, so x cubed divided by 3. We end up with just x cubed plus 3x. We're going to plug in 0, and we're going to plug in 2. When we plug in 2, we end up with 8 plus 6. When we plug in 0, we get 0, so minus 0. And so we end up with f of 2 is equal to 18. Okay. Sometimes these are calculator problems, so we're going to do this next one as a calculator. Remember that the integral of velocity is position. So in this case, if we integrate velocity here, 2 to the 3t squared minus 5, if we integrated that from 1 to 2, well, that would be my position at 2 minus my position at 1. And so if we wanted to find s of 2, we could say that that's going to be s of 1 plus the integral from 1 to 2 of 2 to the 3t squared minus 5 dt. And I'm just going to go ahead and punch that in on my calculator here. And we'll do that as soon as my computer lets me. So I'm going to go down so we can see what we're doing. So we're going to go ahead and integrate this. And go back to this and say, well, s of 1 we know is 8 plus our integral. So we'll say math. Remember we hit math 9. We're going from 1 to 2. And we end up with 2 to the 3t squared or 3x squared minus 5 dx. And we end up with 24.502. Okay, so our answer there ends up being 24.502. All right, well, that's all I got for us today. So hope you are doing well and this stuff is making some sense. And we will talk soon. See you guys in class. Hope you guys are doing well.